Lesson 57, Ideal Gas Laws, page number 245. I'm going to give you the formula, the general ideal gas law equation, which if you're going to take chemistry, you will have to learn. It's a very, very simple equation. And a lot of other equations, Boyle's, Gay-Lussac, and Charles' laws, all have to do with this ideal gas law, just different parts of it depending on what we're messing with. All right, so what that stands for is initial pressure times volume over temperature equals final pressure times volume over temperature. Okay? So what we're going to do in this is I'm just going to give you numbers. You're going to plug in, you're going to solve for the variable. So you're given 6 variables. How many variables do you have to solve this? 5.
Yeah.
Or at least be told something about the other ones that they're not going to give you a number for, and you go from there, which we'll do a couple of those too. This is really a pretty simple lesson. So, let's look at one. Top of page 246, example 57.1. What I suggest doing is make a P1, P2, V1, V2, T1, T2 chart, so you can start plugging numbers in here before you start putting them into formulas. So, it says top of page 246, 4 liters of an ideal gas. 4 liters. Are we talking volume, pressure, or temperature?
Volume.
Okay, that would be volume. So, 4. At a temperature of 800 kelvins, had a pressure of 100 newtons. Top of page 246.
Do we need to put an L by the 4 since it's liters?
Oh, yeah. Might as well put an L by the 4 for liters. Okay, so we've already got 3. If the volume were increased, so we're taking that initial stuff and we're making a change to it in our final one. Okay? If the volume was increased to 10, so if my volume was increased to 10, so my V2 changed to 10, and the temperature was reduced to 600, what is my pressure? What is my P2? Okay, so I've got all this information. Now I just have to put it in my formula here. 100 times my V1, which is 4, over my T1, my initial temperature, equals P2, which is what I'm looking for, times V2 over T2. And what are you going to do to solve for P2, Kendra?
Times 610 each side.
Okay, you've got to cross multiply. So 100 times 4, bless you, times 600 equals 800 times 10 times P2. Multiply those out, divide, you find your pressure to be 30. And you're done.
These are pretty easy.
So yeah, that's really all there is to that lesson. Okay?
Don't erase it.
We're going to do one more example when I don't give you as much information and it just makes the problem easier rather than harder. Which is kind of an anomaly, isn't it? You guys know what anomalies are? Yeah, something that's not normal. Something that shouldn't work. Yeah. Who's an anomaly? Mylan is an anomaly.
I know.
Not normal? Is that what you mean?
That's an anatomy.
Okay. You guys need that back up there? Did I get rid of it too soon? Isn't it nice that it's not actually a chalkboard and it doesn't
If
have
you
to be
erase
over
it,
there?
it would never come back.
That'd be sick if a chalkboard could do that. So I wrote undo.
Question now.
Okay, you ready, Michael?
Does P2 equal 30?
You ready? Okay.
Yes.
So if I have 3 times 10 over 6, don't write this down,
Okay.
times 3 times 20 over, let's make it 7. Okay. Notice that both of these problems have a 3. Does not matter if they're 3s or 4s or what number they are. If they're the same, what, Tim? You just don't put them in there. They don't exist. So if they tell you that we're gonna start out at a certain pressure, but we're not gonna change the pressure. Let's just change the volume, okay? And change the temperature, but we're not gonna change the pressure. You don't have to include the pressure because they cancel, okay? So what will happen when you get to ones like 57.2? It says, well, let me write the equation here first. P1 V1 over T2, 1 equals P2 V2 over T2. It says here the initial pressure was 400. So 400. And the initial temperature was 1200. The volume was held constant. If it says the volume or anything was held constant, you don't have to put it up there. So you just leave the volume out there, and you have to leave it out there because if it's constant, it's the same in both parts of the equation. What was the pressure if the temperature was 900? So now you're looking for that. So now you're just cross multiplying that without having to multiply times the volume at all. If it says temperature is constant, then you leave the denominators off. You just use PV equals PV. Okay? And those are those different laws. Charles' law, Boyle's law, Gay-Lussac's law, is just using different parts of this equation instead of the whole thing. Okay? So that's pretty much it as far as the ideal gas laws. So it's
Does
a
it
pretty
equal 300?
simple
It does.
lesson there.